Okay, I'm back now. So to pick up where we left off, I'm going to go back here to OneNote, and we've got, so we figured all these on a per pound basis. Next thing I would do is calculate how many dollars worth of each of these ingredients we have in our 1 ton ration. So what I can do is take each of these. So I guess the ones I'm focusing on here in this ration are the premix, soybean meal, and Milo. But I don't actually even use the corn here. So for the premix, I have 0.6612. That's dollars per pound times 110 pounds. If I want to put that over one, I can. Then this way the pounds will cancel out. And what that does is give us $72.73. That's how many dollars worth of what is that premix we have in 1 ton. Then I can do the same thing for soybean meal. So up here I said that's 0.2875. So 2875. That's dollars per pound. I have 350 pounds of that. If I multiply those out, I get $100.63. That's how much dollars worth of soybean meal I have in 1 ton of my feed. Finally, we have Milo. So Milo is, we say, 12 over 12 cents per pound, and we have 1,540 pounds of Milo. Put that over one if I want, and okay, and you multiply those together, you get 185.72. So rounded to the nearest full cent. Okay, so now if I add the three of those up, 72 plus 100 plus 185 and odd cents, we get $359.08. So that's per 1 ton feed. But I'm wanting to know, so that's for 2,000 pounds. I'm wanting to know what's the cost per pound. So I could show this units cancellation, but I think at this point, if you know it's $359.08 per ton, and you know a ton is 2,000 pounds, you can divide 359.08 by 2,000. You do that, you get 795 per pound. So almost 18 cents. If you want to round it to 18 cents, I'd be fine with that per pound. So that's the answer to number 5. Okay, so let's go ahead and look at number 6. Using the info from above, how the ration costs change if corn was substituted for Milo at a cost of $16 per hundredweight. I'm not going to do that one. That one's pretty darn similar. Use the same approach as we did on the previous one. I've got the answer on the answer key. All right, finally, the application rate, gallons per acre of a field sprayer is given by this. So we have some formula here where 5940 is a units conversion. It's a constant. So we do that times the flow rate per nozzle, and that has to be in gallons per minute. Divide all that by miles per hour times nozzle spacing. So what size of nozzle is required? So we're solving for the flow rate per nozzle. We're solving for that gallons per minute. So we've got gallons per acre equals 5940 times, this is our flow rate or gallons per minute. So I'm just taking this right from what's on the sheet, over miles per hour times NSI, nozzle spacing. We're solving for this one here. How do we solve for that? Well, we can multiply both sides by the denominator over here and then divide that whole product by 5940. So let's go ahead and plug in what we know. So we want 20 gallons of spray per acre. We got 20 gallons per acre. Can't write an A very well for some reason. Equals 5940 times, this is our gallons per minute, so I'm just going to call this GPM, over miles per hour, so we're going 10 miles an hour, and MPH times nozzle spacing, which is 60 nozzles at 18 inches. So this has to be an 18. So this down here equals 180. We can see that right now. So I can go ahead and do that first, and then I can multiply both sides by 180, and that gets rid of our denominator over here on the right. So take 180 times 20, which is this 20 right here. I'm taking 180 times that. That's what, 3,600? 3,600 equals 5940 times GPM. So GPM equals 3,600 divided by 5940 equals what? Answer looks like 0.606 gallons per minute. So this one isn't so much of a units cancellation problem as it is just being able to solve for an unknown.